So the last section I wanted to cover is called the algebraic expressions. So let's call this maybe, okay, let's add this, call it number 7. Simplifying, algebraic First, we need to identify them. We need to know what an algebraic expression is before we see how to simplify algebraic expressions. Can anyone give us a definition? Quick one. What is an algebraic expression? It's very simple. It's not as fancy as it sounds. Anybody? What's an algebraic expression? It's simply a combination of what?
Numbers and variables.
Numbers and letters, that's right, variables. That's all that what an algebraic expression is, a combination of letters and or numbers and letters or variables. And letters. Numbers, another name for numbers is constants. Because they don't change, the value of a number is constant, so we call them constants. What's another name for letters again?
Variables.
Variables. Variables. That's all what an algebraic expression is, just when you combine numbers and letters. Examples. X plus 1. That's an algebraic expression. There is a letter, there is a number. It could be as short as this, or it could be maybe it could be 2x, could be 3x plus 4y minus 1. Could be 1, 2 letters, could be many, or could be the same variable to different powers. For example, x to the third minus 2x to, I don't know, to the second plus 4x minus 7. That's also an algebraic expression. Again, we just combining numbers and letters. Okay, and when we have these, 2 or more of them, we can combine them or we can simplify them. Okay, so for example, if you have, let's say, 3x minus 7 plus 8x minus or plus 11. So that's an algebraic expression with what we call terms, 1, 2, 3, and 4 terms. Is there a way to make this simpler or shorter by simplifying it?
Yes.
Okay.
Combine the x, the 3x and the 8x.
That's right. What do we call those? 3x and 8x. We combine them. What do we call them?
The variables.
They are the variable terms. We also call them like terms because they're similar.
Right,
like terms. Okay. Same way, we're going to combine which numbers?
And then the minus 7 and the 11.
That's right. That's what we call combining like terms. Okay, so we take 3x and we bring the positive 8x next to it. So each term has its sign to the left. So when you move a term, when you use the commutative property to move a term to another location, make sure you bring the sign with it, which is always to the left. So this is 3 minus 7. This means the negative sign belongs to 7. What is the sign of 3x?
Positive.
positive, invisible positive here. So we're going to bring the positive 8 next to its similar or like term. Then we're going to take the negative 7 with the sign and bring it over to next to positive 11. It's what we call combining like terms. Now we can simplify. What is 3 of something plus 8 of the same thing? For example, $3 plus $8 will be 11. So X is a variable, is unknown. It could be anything. It could be money. It could be people. It could be fruit. It could be basically anything. So just plug, for example, dollar sign inside instead of the X. It would make probably more sense. So that's 11X. Be careful of the signs here. What is negative 7 plus 11? Negative 7 plus 11 is
Positive 4.
Positive 4.
That's right. Positive.
Positive 4.
So pick the sign of the higher number. So 11 has a higher absolute value than negative 7. So you pick the sign of the higher number. Then you do the difference. Please mute your mic and keep it muted if you have background noise, okay? And that's basically it. So you have 11x plus 4. And these can't be combined because they're not like terms. These are like terms, 3x and 8x, but these are unlike. Terms. So that's basically the final answer. You can't add 11 and 4. This one has x, this one does not have x. We don't know what the x is, so we can't just add these two. It could be different things. They are different things. They're unlike terms, so we can't combine. So that's basically how you simplify algebraic expressions. Does that make sense so far to everybody?
Yes.
Yes.
Please let me know if you have any questions. I'm going a little fast over this because I know it's no big deal, but please feel free to stop me if you have any questions about any of the stuff we've covered so far. Let's do one more example here. So let's say that 3 minus 2, say 4x minus 1, and minus 5x. So simplify, again, I want to simplify this algebraic expression as much as possible. It doesn't have to be that long. It could be made much simpler. So what do you think you do in order to simplify this algebraic expression? Where do you start from?
Distribute the -2 into the parentheses.
Exactly. So whenever you have parentheses in an expression, first you want to distribute. Someone has background noise. It's really annoying. Please, for the 5th time, mute your mic, okay? Whoever has the background noise, please keep your mic muted the whole time. Thank you. All right, so again, when you see parentheses, the first thing you want to do is distribute to clear the parentheses. Do not do this first, just because it's the front doesn't mean it has to be done first. So we're thinking about the order of operations. Basically, we're multiplying. So try to simplify inside if you have anything to do inside. If not, you move on to the next thing, PEMDAS. So P for parentheses, E for exponents, we don't have exponents, and then M for multiplication. So multiplication is here. So we're going to distribute this, not addition and subtraction. That's the last thing you want to do in PEMDAS. So 3, here we have negative 8x. And then, what else?
Positive 2.
Right, positive 2. Finally, negative 5x. This, we just bring it over, we bring it down. We don't multiply because it's not inside the parentheses. And now, once you clear the parentheses, what do?
Combine like terms.
Exactly, so we're going to combine. You can start with the numbers or letters, it doesn't matter. So 3 and 2. So it's positive 3 and positive 2. That's
5.
And you have negative 8 minus negative 8 and minus 5. Okay, they both have x, they're like terms. So we're combining the numbers with the sign. So we have negative 8 here, negative 5, which is
Negative 13.
That's right, negative 13x. And that's basically it for that example. It doesn't matter which one you write first. You could write the negative 15x first, but it's still the same thing. If you move it to the front, just make sure you move the sign with it. And that's the final answer. Okay, that's basically how you combine like terms or simplify algebraic expressions. Let's do one more example. So you may run it into something like this. S minus maybe 4x plus x to the third plus maybe 8x. So we have an algebraic expression here with 1, 2, 3, 4 terms. We're going to see if we can simplify this, make it shorter with less terms. We have 4 terms, 1, 2, 3. Notice that when we simplify, you end up with a much smaller expression. For example, here we had 1, 2, 3, and 4. We simplified it into just 2 terms. So it's better to have a simple expression like this. Now, what do you think we combine? Start with the first term. Do we have a similar term to the first one? Yeah,
No.
to the fifth?
No.
No. So it has to be exactly the same. It has to be the same variable to the same power. We don't have any other term with 5x or x to the fifth, so this stays the same. So you cross that out, it's done. Then you move to the next one. Do we have a similar term to this? By the way, what is the power of this x?
1.
1, invisible, 1, right? This one has 5. So these are unlike terms. They're not the same, even though the variable is the same, but the power is not the same. We can't combine them. We can't add or subtract. We're going to see later in a future class that we can multiply, but at this point, we cannot add or subtract. Do we have a like term to this?
Yes, the 8x.
That's right. X, also power 1. We can multiply, combine these. So negative 4 and positive 8. What is negative 4? Positive 8 plus 8?
Positive 4.
Positive 4.
Positive 4, that's right. The variable stays the same, okay? Do not add the powers. Only add or combine the front of the coefficients in front of the variable. We'll be careful with the signs, so negative 4 plus 8. Finally, do we have a similar term to this one? Positive?
No.
Just
Drop it down.
bring it down. Okay, and that's basically it. So we have 2x to the fifth, 4x to the first, x to the third. These are different terms. They're not the same. So basically, we cannot add them. We cannot subtract them because they have different powers. We can do one little thing here to make it a little more simpler, a little more convenient. What do you think we can do as a final step here? It's almost, you can consider it done, but we can do one more thing. We can just arrange the powers in descending order. The powers of the variables, start with the highest one, 2x to the fifth, followed by positive x to the third. Again, when you move something, just move this basically to the next spot. Make sure you move the sign with it, and we can move this back, positive 4x. This is a better way to write expressions in a descending orders of powers. Okay, it's still be okay here, but it's probably better to do it this way. We're going to talk about the orders and the powers later in another class when we talk about polynomials. This is the degree of this expression because it's the highest power. And that's basically how you simplify expressions. So like terms must have the same one. Like terms must have the same. What is it? When you combine two terms or two in an expression, they have to have the same variable and the same
Power. Exponent.
That's right, exactly the same power exponent. So like terms must have, otherwise we wouldn't be able to add them. So must have the same variable and power.
I have a question. Let's say you was rearranging the equation,
Mhm.
and for example, if it was 2x to the fifth power minus 4x plus x to the third power, if you was to rearrange it, would it make a difference being that it has different, like it's subtracting instead of adding?
It wouldn't make a difference. Just make sure if you had a minus here, you said, right? For example, you had a minus here.
Yeah.
So basically, just if you move this, move it with the sign, so it will become a negative. Okay?
Okay.
It wouldn't make a difference, minus or plus. Just make sure you move the term with its sign to wherever you want to take it. So each term has its sign to the left of it. If this was a negative, you just move it with it. Okay?
Okay.
And that's basically how you arrange for in a descending order of powers. And again, this means these two are not the same terms. Even though the variable looks the same, the powers are not the same. So like terms must have the same variable and power in order to be combined. If not, just leave it like this. Don't continue adding or subtracting anything. That would be the final answer. Okay, makes sense, everybody? Everything we talked about today?
Yes.
Yes.
Okay,
Yes.
this was a slightly an easier class. Okay, so just basically a little bit of review of concepts you already know. Just make sure you know your signs, you know your like terms. Remember the subgroups of real numbers. Be able to identify which number and to which subgroup or groups it belongs. And just basically remember your property, okay? We talked about a few of them. So we saw the absolute value. It just makes everything positive. Commutative property, that's when you switch the places. And the result is the same. The associative property, we don't switch the places, we just switch the parentheses. We switch the position of the parentheses, but we still get the same result. Both of these apply to addition and multiplication. The distributive property just means distribute, but be careful with the signs, multiply your signs first. The sign here is not always the same, it changes sometimes depending on the sign on the front. The inverse property, we have two of them, one for addition. That's when you get the opposite of a number. You combine any real number x with its opposite, it's always going to be 0. That's inverse property of addition. Don't confuse that with inverse property of multiplication. In multiplication, that's when you take the reciprocal, not the opposite. So the opposite changes the sign. The reciprocal is when you flip something upside down, it turns into a new fraction. And if you combine a fraction and its reciprocal, it's always 1. No need to do the multiplication or to simplify, just write 1 right away. For example, here, we know for a fact that these two are reciprocals. Their multiplication is 1. Finally, for any number, if it's not a fraction, it can easily be a fraction. Just put 1 underneath the number. For example, if you have just x, you want the reciprocal of x, just turn it into x over 1. You flip it, you get this. If you times x and its reciprocal, x and the reciprocal, you get 1. Okay, same concept as this, or you can think of it as x and x cancel out to get 1. Okay, identity property, pretty simple. Just remember 0 does not change addition. So 0 is the identity of addition. And 1 also, the number 1 does not change multiplication. So it's the identity of addition or multiplication. Finally, simplifying, basically just adding and subtracting the numbers next to the variables or the numbers themselves, the constants. And if you have parentheses, make sure you get rid of those first. You distribute them, but work inside parentheses if possible. If you can add any like terms, for example, if you have 4x here and you have 1x, this was an x, then you would simplify this first. It would be 4x minus 1x, which is 3x. Then you do the distributive property. But if you don't have that, if you don't have anything to simplify, you move on to the multiplication, then combine like terms, and everything is about signs. So make sure you know all your signs: addition, subtraction, multiplication, and division. Review those. Those will be used extensively in this class, so make sure you understand them very well. And if you have any confusions, any questions about them, please let me know, because we're going to be using them throughout this class. And one little wrong sign can make the whole thing wrong. Okay, so and be careful when you multiply your terms, your numbers, and when you add or subtract, always look at the signs of the numbers first, and then apply the appropriate operation. For example, here, this is a multiplication. The distributive property is basically just a multiplication. After we get rid of the parentheses, then when we combine, that's when we add or subtract. So combining like terms is 3 and positive 2, that's positive 5, negative 8, negative 5, that's also addition and subtraction. So we're combining into negative 13. But with parentheses, we actually distribute or multiply. So we use the rules of multiplication. And the last thing again to remember here, like terms must have the same variable and the same power. Otherwise, we can't add them. That's why we only added these two, because they have the same variable x to the same power 1. And these two didn't add up. They stay the same. Do not add the powers. Do not do anything. They're different. Okay? They're unlike terms. They're not the same. They stay like this. Okay? Everyone on board? Any questions, everybody?
Yeah, for the recording of this, just in case we want to like review it, do you have to send it to us, or is there anywhere we can access it?
Okay, very good. I'll upload this. I showed you guys what I post the YouTube videos, right?
Yeah.
Post resources. Oh, you'll see that this one there as well. Okay, I will create a new playlist for all the lectures. Probably gonna call it college algebra lectures or something. So I'm gonna post all those there. So you'll find this. You can rewatch it whenever you want. Okay, so I'll post it as soon as I can. May have to edit it a little bit. Remove the stuff that's unnecessary. The beginning before we started. And okay. Any other questions, everyone?
Professor, do we got homework or something?
Let's see. Not yet. Maybe after what is this, Thursday?
Yeah.
Okay, probably give you one on this, probably. Just look out on Blackboard. Blackboard, so probably post one on the stuff we did today because we have the whole weekend until Tuesday. So we'll probably give you one homework on this, okay?
Okay.
Just check the homework folder later. What else? Any other questions? Okay, let's now take your attendance. And we'll continue with this after this. Continue on Blackboard. If you have any questions, let me know. And all right, Romani.
Yes.
Here. Ciro.
Here.
Okay. Cruz Milan.
Here.
Milan here. Jeffrey.
Here.
Nejla.
Here.
Okay. Shayna.
Here.
Lakani.
Here.
All right. Layla Net is here.
Present.
Anastasia. Evan Santos.
I'm here, Professor.
All right. And then Aggie.
Here.
Okay, Aggie, I got it. Very good. Almost everyone is here.